This video is the last of our acceleration videos, and it's about a specific case of acceleration called free fall. Free fall is the case where objects are falling and only have one force acting on them, and that's the gravitational force. So there's nothing else happening to them. There's no air resistance. They're not touching anything. There are no other forces acting. Objects that are freely falling, the only force acting on them is the gravitational force. And the acceleration of objects that are freely falling is a constant, regardless of the mass of the object or any other thing. Objects that are in free fall have a constant acceleration, and that acceleration is 9.8 meters per second squared. So what does that mean? That means every second that an object is freely falling, its speed will change by 9.8 meters per second every second. Okay? So if you drop an object from rest, you let it go, 1 second later, it will be going 9.8 meters per second. If you throw an object up into the air, well, this acceleration is aimed downward. It's a gravitational acceleration. It's an acceleration towards the Earth. So if you throw it up into the air, it will lose 9.8 meters per second every second. Okay? So that value, gravitational acceleration, the symbol is lowercase g, is 9.8 meters per second squared. That value can be considered positive or it can be considered negative. As I said earlier, it's always directed toward the Earth. There are some problems that will be easier for you to work out if you consider g to be a positive quantity, and some you're going to have to let it be negative. The way I choose is if there's one direction in a problem, then I let down, well, if there's one direction, it'll be down, I'll let that be positive. But if you throw an object up into the air and it has a path that goes up and then it comes back down, then you've got up and down, and one has to be positive and one has to be negative. And traditionally, we let up be positive and down be negative. In this case, g would be negative 9.8 meters per second squared. So you drop a ball from rest, so the initial velocity would be 0. How fast is it moving 5 seconds later? Well, we can solve this with an equation, but use the definition of gravitational acceleration. Think about how this works. Every second an object is falling, it gains 9.8 meters per second of speed. That's what acceleration is. So if it falls for 5 seconds, then it's going to have a change in speed of 5 seconds times 9.8 meters per second squared. And 5 times 9.8 is 49 meters per second. So if you drop an object, 5 seconds later it's falling 49 meters per second. Okay, let's do this with an equation. So all of the equations that we used before still work. So think about those equations. There's the definition of acceleration. A is change in velocity over change in time. Now we're going to write that as g is change in velocity over change in time, because our acceleration is 9.8. It's not a variable anymore. Acceleration in free fall problems is a constant. We had the equation vf squared equals vi squared plus 2ad, so we'll say 2gd. And d equals di plus vit plus 1/2, not at squared, gt squared. Okay, so in this problem, if we want to know the velocity and we know the acceleration and the time, then we would use this formula, and our change in velocity would be equal to gt. And isn't that just what I did? Here's t and here's g. So whether we reason through using the definition of acceleration or we use the formal equation, we get the same thing. So that's how fast it's moving. How far will it fall in 5 seconds? So you drop an object. How far will it have fallen 5 seconds after you drop it? Well, let's look at these equations. This one would work. So let's write the equation. D equals di plus vit plus 1/2 gt squared. So think about the direction a minute. We're dropping, so we're going to let down be positive. So we don't have to worry about g being negative in this problem. If we drop something, then its initial position, we're going to call that 0. So if you have a ball and you're going to drop it, and that ball is going to fall to the floor. We let this be 0, and then this is positive. So this might be, 1 meter of motion, depending on how high you hold your hand. So it could be 2 meters or it could be 0.75 meters, but we're going to let positive be down. So our initial position is 0. If you drop it, the initial velocity is 0, so that'll make that term 0. So this big ugly equation turns into just d equals 1/2 gt squared. So our distance that it falls will be 1/2 times 9.8 times, and the time was 5 seconds, squared. So I'll use my calculator, 0.5 times 9.8 times 5 squared is 25. So 122.5 meters. Pretty simple. Okay, let's try some more examples. So this section has a few definitions, but it's mainly applying these, the same equations, but in free fall type situations. You throw a ball upward with an initial velocity of 3 meters per second. How long does it take for the ball to reach the peak of its path? So when it reaches the peak of its path, that's kind of physics code for the final velocity is 0. At the peak of a projectile, at the peak of a freely falling object's path, the velocity is 0. That's why it's the peak. It stops there and turns around and falls back down. So we know the final velocity is 0, and we know the initial velocity is 3 meters per second. We know what acceleration is. It's g. So we have an equation with acceleration and initial and final velocity. Yes, we do. Acceleration is a change in velocity over time. If we want to know the time then is change in velocity over g. It final minus initial. 0 is the final. 0 minus 3 over, and g is, we're going to let it be negative. Oops, yeah, it's 3. Okay, so 3 divided by 9.8 equals 0.3 seconds. Now, let's talk about this sign here for a second. Why did I let g be negative? Well, because my final velocity was positive, 0, and my initial velocity was positive. So this initial velocity was upward and it was positive, so g, since it's downward, had to be negative. And a little clue, if you ever come out with a negative time, you've done something wrong. Time is always going to be a positive quantity. So what maximum height was reached by the ball? Remember this equation, d equals di plus vit plus 1/2 gt squared. So our initial height is 0. We're throwing this thing up into the air. So the initial and final height will be 0. And we're talking about maximum height is the question. So we want d. Di is 0. Now, initial velocity is not 0 in this problem. It's 3. The time is 0.3 seconds. Now, 1/2, this is going to be negative 9.8 times t squared is 0.3 squared. So 3 times 0.3, I can do that in my head, 0.9. This is going to be a minus because that negative 9.8, when it multiplies through, is going to turn this into a negative. So 0.5 times 9.8 times 0.3 squared, I get 0.441. So if I say 0.9 minus 0.441, I get a distance traveled of 0.359 meters. You guys need to watch your units and pay attention to what you're solving for. I'm getting way too many distance answers that are meters per second, or acceleration answers that are meters per second. If you're solving for a distance, your answer better be in meters, nothing else. How long does it take the ball to return to its initial height? Well, think about this. The ball goes up and the ball comes down. You don't even have to solve for it. If it returns to its initial height, it's going to take just as long to fall as it did to go up. So in this case, we don't have to solve the problem. Time is 0.3 seconds. And how fast will the ball be moving? Well, if it took 0.3 seconds to lose 3 meters per second of speed, and then it falls for 0.3 seconds, it's going to gain that same amount of speed back. So when an object reaches the same height, whether it's the initial height or some other height in the path, when it gets to the same height, it'll have the same speed. So it'll be going 3 meters per second, but it'll be going downward. So it said how fast. It didn't say speed or velocity. The speed would be 3, but the velocity would be negative 3 meters per second. Okay, at some point, whether it's on the test for this chapter or on a quiz for this chapter, at some point you are going to be asked the question, what is the acceleration of an object when it reaches the peak of its path? So at that point, what's the acceleration? Most of you are going to tell me that at the peak, acceleration is 0. And that's wrong. So I'm telling you now, when I ask you this question, at the peak of its path, the velocity is 0, yes, but acceleration of any object in free fall, no matter where it is, at the beginning of its path, at the end of its path, in the middle of its path, the acceleration of a freely falling object is g, is 9.8 meters per second squared. Okay, so be prepared. I'm going to ask you that question. And I would really, really like it if most of you got it right. Okay.